Hello, students. Welcome back to Unit 2 Basic PLC Programming. In the last session, we went through different types of input instructions and the output instructions, the devices which can be connected to the input module and output module of PLC. So, in the last session, we have seen various types of input instructions like normally open contact, normally closed contact, latch unlatch system, rising edge actuation, and the falling edge actuations. Then in the output instructions, we also saw different types of contacts like OTE, NOT. So now in this session, we'll use these contacts and coils to program a PLC. So in this session, we'll discuss about three applications where these are the simple applications or basic thing you should know. So these are the simple programming examples I have taken. And the first example you will be studying is the simple one contact and coil circuit. Then we'll move on to the second example, that is a standard start stop seal circuit. Then at last we'll move on to standard forward reverse stop with the mutual interlock circuits. So let's quickly begin this current session. So this is the example wherein we use one contact and one output coil. So this is very simple circuit I have taken here. So you can see two diagrams here. The first, diagram on the left is a logic diagram, and the diagram to the right is the connection diagram here. So first we'll understand what this diagram represents. Okay. So here you have, here I've written a PLC, and here you have the PLC logic circuit, and this logic circuit is programmed using a ladder diagram. That is in the first session, I told you about the various languages where they are used is in order to program the PLC logic circuit. Inside the PLC module, we are using those languages. Here I have taken a ladder diagram to program the logic circuit inside the PLC. So the diagram to the left is a ladder diagram, whereas this diagram to the right is shows only the connections. So here you have a logic circuit here, and this circuit is replaced by this ladder diagram. And here you have the terminals here. These are all the input terminals. You have a common terminal, then terminal number 1 to 8. These are the input terminals. For these terminals, you can connect the PLC input devices like the switches and sensors. And here you have a common terminal, then terminal 17 to terminal 24 I have shown. And these terminals are called as the output terminals. Here you can connect the output devices like a motor, meters to take the measurements, then buzzer lights, the pilot lights. All these things can be connected to the output terminals here. Now you see here I have shown SW1, and this SW1 represents a switch here. So SW1 switch is used to start a output device. So whenever this SW1 switch, I have taken that switch to be normally open switch, NO switch I have taken. So when SW1 is energized, so how you energize this switch is by pushing it in case of a push button. So if you are using a push button for SW1, in that case you can energize the push button by pressing it. So when I press the push button, here, this SW1, it comes and it falls over here. This arm comes and falls here. So your SW1 will be closed here. So when I close SW1 switch, then at the output here inside you will be having a output coil, and that coil will be energized, and for that coil you are connecting a motor. So when that coil is energized by pressing this SW1 switch, your motor will be turned on. That is when I energize or when I press the start button, which is a push button, the motor will be turned on. And what happens if I open the SW1 switch? That is, I release the push button. In case I release the push button, in that case, this arm shown in the diagram will fly back to its normal position. So you will not be applying this voltage to the input terminals. In that case, that is when I release the push button, thereby I am opening a start switch. In that case, the output coil is de-energized and motor is turned off. So the same here I explained the working of a switch connected to a motor. In between you have a logic circuit, PLC logic circuit. Now we'll see the same working you can observe or you can see in the ladder diagram. Now we'll concentrate on the ladder diagram. So the last session, I said that the ladder diagram uses the fundamental parts the power rails and rungs. So the two vertical lines in this ladder diagram, it represents the power rails. They carry the voltages, whereas the horizontal lines are called as the rungs. And here I can place the contacts and the output coils, and the output device is connected to the output coils. And here, so these vertical lines are the power rails, whereas this horizontal line is called as a rung here. And this is IN001 contact, and this is normally open contact. And this SW1 switch, that is the push button you are using to start and stop the motor, that is represented using the contact IN001 in the ladder diagram. So it is a normally open contact. And then you have the output coil here, which is named as CR017. So CR017 is the output coil, and any output device, if it is connected to this output coil, will be turned on only when this output coil is energized. So I'm connecting a motor to this output coil in this example. Now we'll see how the ladder works here. When I said it's a normally open contact. So under the normal operations, it will be open. By default, it is open. Whenever I energize the contact by pressing the push button, in that case, this contact will be closed. When this contact closes, there is a connection between the two power rails. So current flows in this rung. When current flows, this will energize the output coil. Since the coil is energized, the motor which is connected to this coil will be turned on. Now we'll see the second situation when I open this contact. So your motor will be running. It has started. Now what I do is I will open circuit or I'll open this contact by releasing the push button. So when I release it, so this arm, I said it flies back to the original position. So in that case, the contact IN001 becomes open. So the contact, it will be open when I release the push button SW1. So when contact opens, there is no connectivity between the two power rails. Hence, no current flows in this rung. So your output coil CR017 is de-energized. Hence, the motor which is connected to the coil will be turned off. So in this example, what we should observe is that to turn on the motor, I am using the contact IN001 or a switch SW1, and to turn off the motor, I am using the same switch SW1. That is, to start the motor and to stop the motor, I am using a single switch SW1. So this fact you should remember here, that is to start and stop. To do both the operations, I am using a single switch. Next, we'll move on to the second example, which is a start, stop, and seal circuit. So first, we'll see that the here. I've taken a start here. So one button will be used to start the motor. The second button is used to stop the motor. And later on, we'll see what a seal circuit is or seal contact is. So first, we'll concentrate on start switch here. Here you could see the connection diagram here. So I have taken a start switch here, you can see. So it is a push button type of a switch. So I've taken a start switch and it is connected between the terminals, the common and terminal 2. Whereas stop button also I've taken and it is connected between the terminals common and terminal 1. And as we discussed in the last session, that is the second session, I told you that normally open contacts, so they are used to represent a start button, whereas normally closed contacts will be used to represent a stop button and emergency halt buttons. So the same case here, I've followed. I've followed the same rule here. Here I need to start the motor. I have taken a start button, and in the ladder diagram it is taken as IN001, which is normally open. Here you can see it is normally open. I've taken a normally open switch to start the operation. And for the stop switch, it is taken as normally closed switch. As this concept we discussed in session 2, I believe. So for a start button, I'll be taking a normally open switch and normally open contact. And for the stop switches, I'll be considering normally closed switch and normally closed contacts. And at the output side, you can see a motor is connected between the terminals common and terminal 1. So in between you have a PLC logic here, and this logic is nothing but this ladder diagram, which is shown to the left. Now here let me explain you about this ladder diagram. This IN001, it is used to start the motor. So it is a start contact, and it is taken as normally open. The second contact is iron 002. This is normally closed contact, and this represents the stop switch. So IN001 is the start switch, IN002 is the stop contact. And as usual in the previous example, I should have a output coil also, and CR017 is the output coil. A motor which has to be turned on and turned off is connected to the output coil CR017. Now let's learn how this ladder diagram works. Okay. First, in order to start the motor, this is the initial condition I have. I need to start a motor, then I will energize the start switch so it closes. So when it closes, your motor will be turned on. Motor is turned on when I close the start switch. This will turn on. And here okay, the motor will be turned on. Now, what I'll do is I will open this start. I'll release this start switch. In that case, your motor is turned off. But I don't want that type of a situation. What I want is, what my application requires is that when I press the start button, the motor should start. Okay, then even if I release the start button, then also motor should continue to be turned on. And to off it, I need to press a stop button. Only when I press stop button, it should stop working. So I think the situation is clear to you. Let me repeat it once again. When I press the start button, your motor should start. It should be turned on. Even though I release the start button, that is, I open the start switch. In that case also, the motor should continue to be turned on. Then to stop the motor, I need to press the stop switch. Only in that case, when I operate a stop switch, in that case, motor should turn off. So this is the situation, and I have explained you about the situation. Now you need to write a ladder diagram or design a ladder diagram which matches with your problem. Now I've taken IN001, and this is a contact, a start contact, and it's a normally open contact. We also have IN002, it is a normally closed contact, whereas IN001 represents the start switch. The contact IN002 represents the stop switch. Then we have the output coil CR017. And I have introduced one more concept here, that is sealing concept. Here you can see there is a contact called as CR017, and it is normally open. So this is called as a seal contact. Now we'll study why we need a seal. Okay, as I said, explained in the connection diagram here. So see here, I'll start the motor by energizing the contact IN001. So when I energize, 001 will close, whereas IN002 contact is normally closed. So this is closed, and when I energize, that is when I want to start a motor, I will energize the contact IN001. So this contact is also closed, and there is a continuity in this rung. The power, that is the current flows in this rung. Thereby you are energizing the coil CR017. So when this is energized, a motor connected to the coil will be turned on. So it starts running. Now, what I do is I'll release this. I'll de-energize the contact ion 001. When I de-energize the contact, it goes back to the normal condition. That is, it becomes open. When this becomes open, in that case, your seal contact CR017 will come into the action. That is, this seal contact will be turned on or it is energized when the output coil is energized. So whenever the output coil is energized, at the same time your contact CR017 is also energized. So when we started the motor by energizing the contact ion 001, your output coil is also energized. At the same time, the contact CR017 is also energized. And when this is energized, so it will close. The contact will be closed. So even when I de-energize the start contact ion 001, there is a continuity in this alternate path like this. So your current can flow between the rails from ion 002 contact CR017 and then to the output coil. Thereby the motor continues to run even though I de-energize the contact ion 001. So this action is called as a sealing action, and this sealing action is achieved using a contact CR017, a seal contact. So a seal contact is always, you can see from the diagram, it has to be connected in parallel with the start contact because it has to provide an alternate path whenever the start contact is de-energized. So it has to come in parallel with the start contact. Now, okay, motor is running. Now I need to turn off the motor. In that case, I should operate a stop switch. So when I energize stop switch, it opens. So when the contact ion 002 opens, there is discontinuity between the power rails, hence no current flows through the rung and the output coil CR017 is de-energized. Thereby the motor is turned off. So this is the standard start, stop and seal circuit. So here in the earlier, the first example we saw, we used only one contact and one output coil and only one switch was used to start as well as stop the motor. Whereas here in the second example, I made the situation quite difficult by introducing a seal contact. Yeah. So even when I release the start switch, your motor should continue to run. So thereby I made a situation little bit difficult for you. So I think now the purpose of seal contact is clear to you. Next, we'll move on to the another example. Now I'll make the situation much more difficult by including this mutual interlock concept here. So first we'll go through the connection diagram and how it works, what is the situation we'll try to understand. So this is the connection diagram here. So I have used to start here what I want is the motor has to run in two directions now. It has to run in forward direction when I press forward start button and it can also run in reverse direction also and to change the direction that's from forward to reverse or reverse to forward I need to operate a stop button. That is, whenever a change in the direction is required, a stop button has to be operated. And here you see here. So this is the forward start switch I've taken, and it is connected between the common and terminal 3. Then I have this start forward. I have start forward have taken, and it's connected between one common and terminal 2. And also to start the motion in reverse direction, I have taken a switch uh, that is start reverse, and connected between the terminals common and terminal 3. Then I have a third switch stop, which is connected between the terminals common and terminal 1. Then here I have two drives. F indicates it's a drive which helps in moving in the forward direction, and that is connected between the common and terminal 17. Then I have the drive R, which helps in moving in a reverse direction, and this is connected between the terminals common and terminal 18. Okay. Now, I think you understood the situation. The situation is that in order to have motion in the forward direction, I will have a forward start switch. Then I want a motion in the reverse direction. Then also I'll be using a start reverse switch. And to change the directions, I'll be using a stop switch. Here we'll see how this ladder works. So here you have IN002 contact. It is normally open contact, and it is used to represent the start forward switch. Then we have IN003. It is normally open contact, and it represents start reverse switch, start reverse switch. Then I have a stop button to represent a stop switch. The contact IN001 is used. Here it is used in both the rungs, and it is normally closed because it is a stop switch. So I have taken that as normally closed, whereas IN002 and IN003 are the start switches. So I have taken that to be normally open. And then we have the output coil CR017, which provides the forward drive. And similarly, in order to have the sealing effect, which I explained in the last example, I have used a contact CR017, and it is parallel with the start switch IN002. Similarly, CR018 is the output coil, and this provides the drive for reverse direction movement. And to have the sealing uh, effect, I have used the contact CR018, which is parallel to the IN003. So always the sealing contact has to be connected in parallel with the start contacts, so that it provides a alternate path whenever the start contact is de-energized. So this is clearly evident here. So I have used two seal contacts. Then one more point you should understand in this example is that whenever a motor is moving in forward direction, you cannot have the motor to run in the reverse direction at the same time. It is not possible. So at a time, given point of time, a motor should run either in the forward or in the reverse direction. So I need to energize the output coils uh, only one output coil at any given point of time. That is when the forward drive is energized, your backward, the reverse drive has to be de-energized. So vice versa. So because you cannot have the motion in both the directions. So when one is on, one drive is on, forward drive is on, you should de-energize the reverse drive. So that mutual exclusion, what we call, it has to be incorporated in the ladder diagram. That mutual exclusion concept has to be incorporated. For this purpose, I'll be using mutual interlocks. So your mutual interlocks, what they do is it will prevent both the coils it will prevent the both the coils to be energized at the same time. Simultaneously, I cannot energize both the coils, these two coils. So they occur in mutual exclusion. So all such types of events can be represented using what are called as the mutual interlocks. Here in the ladder diagram, you can see here, I have taken a contact CR18 and it is normally closed contact. Okay. And in the second rung, I have taken a contact CR17. This is also normally closed contact. So these two contacts, CR18, CR17, they does the function of mutual interlock, mutual exclusion. Now we'll see how they operate. Assume that the motor is running in the forward direction. That is CR017 coil is energized, whereas CR018 is not energized. In that case, here, since CR017 is energized, the output of CR017 coil is 1 and that will energize the contact CR17. When this contact CR17 is energized, because it's a normally closed contact, when I energize it, it is open. When it opens, there is no connectivity between the power rails in the second rung. Thereby, this reverse drive is not energized. Now, whenever assume that the motor is running in the reverse direction, that is CR18 is energized. In that case, when this is energized, that is output from this coil is 1, then we are using a contact CR18, a normally closed contact. Only when the coil CR18 is energized, the contact CR18 will open. So only when the reverse drive is energized, the contact CR18 is energized. And when this is energized, it will be open. When this contact opens, there is no there is a discontinuity between the power rails in the first rung. Thereby, the forward drive is turned off. So in this way, by using the mutual interlocks, we can achieve the conditions and see that two conditions or two things will not happen simultaneously. So only one condition can happen. So that thing is achieved using the mutual interlock concept. So I think this interlock concept is clear now, and then the seal contact is also clear. Now we'll see how this ladder diagram works. First, what I'll do is I'll start the motion in forward direction. Then I'll energize the contact IN002 and IN001 normally it is closed. So when I energize 002, it closes. When this closes, here, when it closes, there is a there is a closed path between two power rails in the first line because this drive will assume that it is 0. The R drive is reverse drive is 0. In that case, this C contact CR18 remains closed and IN001 is also closed. And when I energize 002, that is the start forward. When I energize this contact, this also closes. So there is a connection between two power rails in the first rung, and current flows and energizes the coil CR17, and hence the forward drive will be energized and motor runs in forward direction. Now I want to change a direction. When I want to change a direction, the thing is that first I need to operate a stop contact. Here, now motor is running in forward direction. Okay. Now what I'll do is I will energize IN001 contact because it's normally open. When I energize, it opens. When this opens, okay, when this opens, there is no connectivity between the two power rails. No current will flow in the first rung. Hence, the coil CR17 is de-energized. Therefore, the forward drive is also de-energized. Now, I have stopped it. Now, I want motion in, I have to start a motion in reverse direction. Then what I do is, I will close this switch. I will operate a start button here. Start reverse IN003. I will operate or I'll energize. When I energize, it closes, and at the same time your stop is also closed because it's NC contact. It's normally closed, and whenever I want to start motion in reverse direction, and IN003 will energize, so this will also be closed, and here forward drive is off here, so in that case it is 0. So 0 will be applied to the contact CR17, hence it remains to be closed. Now there is a connection between the two rails in the second rung. Therefore, current flows in the second rung. Thereby, the coil CR018 is energized. Hence, the reverse drive will be energized. Suppose think that again I need to change. I went from forward direction, then I change it into reverse direction. Suppose that again I need to change the forward direction. In that case, what I should do is first I should operate a stop button. So I will operate this or energize the stop contact IN001. When I energize, this opens up. When this opens, there is no continuity in the second rung. Thereby, reverse drive will be de-energized. Once I de-energize this, now I will operate or I will start running in the forward direction by operating or energizing IN002 contact. So when I energize this contact, this also closes, and this is normally closed. So this is closed, and when I energize this IN002, this also closes, and contact CR18 is also closed because reverse drive is off. So when that is off, it is not energized. So it remains in normal condition. So it is closed. Then forward coil CR17 will be energized. That is forward drive is energized. So I think in this session we went through a lot of new concepts like simple one contact and a coil. Then we also went through the uh, how seal works, and we went through a new concept called as the mutual interlocks. So now, let's recap what we went through in this section. The first thing was that we used one contact and one coil. To energize the coil, I have to operate a contact and then de-energize a coil. The same contact has to be operated. This is a very simpler ladder diagram. Then we went through the second example where a ceiling concept is introduced. That is to start the motor. I am using a start, I'm energizing a start contact. And even when I de-energize, the motor has to keep running. So an alternate path has to be provided. So we used a ceiling contact, CR017, which provides an alternate path, even though the start contact IN001 is de-energized. So we also saw that it has to be seal contact has to be connected in parallel with the start contact. Then, in order to stop the motor, stop switch or a stop contact is energized. Then this is the sequence of operation. That is, to start the motor, I am using a start contact, and to stop the motor, I am using the second contact. So in the earlier example, the first example, we used only one contact to start as well as to stop the motor, whereas in the second example, to start, we are using the first contact, and to stop the motor, we are using a second contact. When we are using two separate contacts like this, then a sealing contact has to be connected in parallel with the start contact. Otherwise, what happens is whenever I de-energize the start contact, your motor will be turned off. I want the motor to continue in the same state, so alternate path is provided using the seal contact. The next example we went through is a forward reverse stop with the mutual interlocks. Here, I want the motor to run in forward as well as the reverse direction. To start motion in a forward direction, I'm using the contact, start contact IN002, and to start the motion in the reverse direction, another start contact IN003 will be used. And here also I want a concept of seal. So I'm using the seal contacts in both the rungs. Then I need to stop the motion. That is whenever I need to change the directions, then a stop contact has to be energized. This is the sequence. So first to start the motion in forward direction, I have to energize IN start contact forward IN002. Now motor is running in the forward direction. Whenever I want to change the direction, then I'll energize the stop contact IN001 will be energized. And again to start the motor in the reverse direction, I will de-energize the stop contact. Then I will energize the contact IN003. And here the mutual interlock concept says that both the outputs cannot occur at the same time. That is, the moving in the forward direction and moving in the reverse direction. These are the two kinds of output. Both the output cannot occur simultaneously. In that case, we need to use the mutual interlock. So I have shown a mutual contact, interlock contacts in both the rungs here. So you can see from the ladder diagram. So CR18 and CR17, these are the mutual interlocks which I have used. Now, I think the concept about the concept of seal, the concept of mutual interlock is clear to you. Next, we'll move on to the quiz section here. The first question is output devices that can be connected to PLC are A. Motor, B. Limit switch, C. Pilot light, D. Buzzer. So the answer is the output devices are motor, pilot light, buzzer. So the option is ACD. ACD is option third. Third option is the correct answer. The second question is PLC input devices are A. Push button, B. Limit switch, C. Selector, D. Motor. The answer is the input devices are push button, limit switch, selectors. It is A, B, C. The choice is choice third, A, B, C. Choice three is the answer. Next, we'll move on to the third question. In start stop seal circuit, the working of seal contact can be described as A. Seal contact opens when output coil goes on. B. Seal contact opens when output coil goes off. C. Seal contact closes when output coil goes on. D. Seal contact closes when output coil goes off. So I have explained about the seal contact. I said that whenever the output goes on, the seal contact will be energized. So a seal contact here, it seal contact closes when output coil goes on. Choice C is the answer. The fourth question is position of seal contact is A. Series with the start contact, parallel with the start contact, series with stop contact. D. Parallel with the stop contact. The answer is position of a seal contact is parallel with the start contact. So always you should take that seal contact in parallel with the start contact because a seal contact has to provide an alternate path whenever the start contact is de-energized. So in order to provide alternate path, you must have a seal contact in parallel with the start contact. So the correct answer is choice B. Seal contact parallel with the start contact. Next question is in standard forward reverse circuit, dash button has to be pressed to change the direction of motion. The answer is a stop button. So when I we were discussing about this sequence of operations to change the directions, I said whenever you need to change the direction, I need to operate a stop button. So answer is stop button. So in the next session, we'll see a few more practical examples like this. Thank you.